Hi, Questers! Today's quest begins with a sensation you are feeling right now, or rather, a sensation you are noticeably lacking. It is a feeling of absolute, perfect stillness. You are sitting in a chair, standing in a room, or lying in bed, and your body tells you that the world is stationary. Your inner ear detects no movement. The water in your glass is flat. The walls are not shaking. But this sensation is a lie. It is a fundamental hallucination caused by the limitations of your biology. In reality, at this exact second, you are tearing through the void at speeds that defy human comprehension. The ground beneath your feet is spinning at nearly 1,600 kilometers per hour. That is twice the speed of a commercial jetliner. But that is just the rotation. Simultaneously, the entire planet is racing around the sun at 30 kilometers per second. That is not 30 kilometers per hour. That is 30 kilometers per second. To put that in perspective, a high-velocity rifle bullet travels at roughly 1 kilometer per second. You are currently riding a rock that is moving 30 times faster than a speeding bullet. You are moving fast enough to cross the entire Atlantic Ocean in under 3 minutes. And yet, there is no engine. There is no massive thruster strapped to the South Pole. There is no fuel tank the size of a continent feeding a combustion engine in the core. There is no cosmic hand pushing us from behind. This presents a paradox that has broken the minds of philosophers for thousands of years. On Earth, everything that moves eventually stops. If you take your foot off the gas pedal, the car slows down. If you unplug the fan, the blades halt. If you stop pushing the swing, it returns to stillness. We are taught that energy is expensive. We are taught that motion requires fuel. So where does the energy come from to keep the Earth spinning? Why hasn't the fuel run out after 4.5 billion years? Who paid the energy bill to start this motion? And why are we not slowing down? If you are ready to understand the physics of the void, the brutal mathematics of momentum, and the ghost of a dead star that is still pushing you today, subscribe and join the quest. Because this story explains why you are here and why you haven't flown off into the dark. Let's start by dismantling the biggest misunderstanding about planetary motion. Most people, if you ask them what keeps the Earth moving around the sun, will give you a single-word answer: gravity. They imagine gravity as a kind of invisible motor, a force that actively pushes or drags the planets through their orbits. They picture the sun as a conductor, waving a baton and driving the orchestra. But this is wrong. Gravity is not an engine. Gravity is a leash. To understand this, you have to look at the physics of a tetherball, or a stone tied to a string. Imagine you are swinging a heavy stone around your head on a rope. You can feel the tension in the rope. That tension is pulling the stone inward, toward your hand. That inward pull is exactly what gravity does. It bends the path of the object. It prevents the planet from flying off in a straight line into the emptiness of deep space. But ask yourself this: does the rope make the stone move fast? No. If you hold the rope perfectly still and don't move your arm, the stone hangs dead at your side. The rope provides the direction, but it does not provide the speed. You provided the speed with that first initial heave. Gravity works the same way. It curves the path of the Earth into a circle, but it adds zero energy to the speed of the orbit. It steers the car, but it doesn't press the gas pedal. So if gravity isn't the power source, what is? If the sun isn't pushing us, who did? To find the engine, we have to leave the solar system as we know it. We have to rewind the clock, not by years or centuries, but by eons. We need to go back 4.6 billion years, to a time before the Earth, before the sun, and before the existence of solid ground. We need to look at the architecture of a molecular cloud. Before our solar system existed, there was only a nebula, a vast, cold, dark cloud of hydrogen gas and dust floating in the interstellar medium. This cloud was not small, it was light years across, and it was not completely still. In the chaos of the universe, nothing is ever truly perfectly still. The gas molecules were drifting. Tiny, random currents rippled through the dust, perhaps stirred by the shock wave of a nearby supernova or the gravity of a passing star. These tiny movements were the seeds of everything we see today. Eventually, gravity began to win its war against pressure. The cloud began to collapse. It fell inward on itself, consuming billions of miles of empty space and crushing it down into a dense core. This is where the physics gets intense. This is where we encounter the law of conservation of angular momentum. This law is one of the absolute unbreakable rules of our reality. It states that if you have an object that is spinning and you make that object smaller, it must spin faster. You have seen this on television during the Winter Olympics. Picture a figure skater. She starts a spin with her arms and one leg stretched out wide. She is rotating slowly, gracefully. Then, suddenly, she pulls her arms in tight against her chest. What happens? She doesn't just keep spinning at the same speed. She accelerates. She becomes a blur. She spins so fast, it looks like she might drill a hole in the ice. She didn't add a motor. She didn't turn on a rocket. She didn't drink an energy drink. She simply changed her geometry. By moving her mass closer to her center of rotation, the universe demanded that her speed increase to compensate. The total amount of spin, the angular momentum, had to stay the same, so the velocity had to skyrocket. Now, take that figure skater and scale her up to the size of a solar system. As our massive nebula collapsed, it acted just like the skater pulling in her arms. A cloud that was light years wide shrank down to the size of a solar system. That tiny, slow, random drift of the original gas particles was amplified 1 billion times over. The slow drift became a roar. The chaotic currents were forced into a single, unified direction. As the cloud collapsed, it flattened out. It turned into a spinning disk, like a chef tossing pizza dough. The faster it spun, the flatter it got. This is why the solar system is flat. Have you ever wondered why all the planets orbit in roughly the same plane? Why we aren't swarming around the sun like bees around a hive, in all directions? It is because of this ancient spin, we are living on the leftover dough of that cosmic pizza. In the center of this disk, the pressure became so intense that nuclear fusion ignited, and the sun was born. But the rest of the disk kept spinning. Inside this swirling racetrack of dust and gas, the violence began. Dust grains collided and stuck together. Pebbles became rocks. Rocks became boulders. Boulders became planetesimals. These weren't gentle mergers. These were high-speed car crashes happening millions of times a day. But here is the key. All of that material was already moving. The Earth wasn't born still and then pushed. The Earth was born from debris that was already racing around the sun at 30 kilometers per second. We were born in the fast lane. Every atom in your body, every drop of water in the ocean, and every rock in the Earth's crust carries the momentum of that original collapsing cloud. The rotation of the Earth, the 24-hour cycle that dictates your sleep, your work, and your life, is a fossil. It is a preserved memory of the angular momentum from 4.6 billion years ago. But this leads us to the second and perhaps more terrifying question. Okay, we got the push from the big collapse, but that was billions of years ago. Why haven't we stopped? If you spin a top on a table, it spins for a minute, wobbles, and falls. If you slide a hockey puck on ice, it eventually halts. If you turn off the engine of a boat, the water drags it to a stop. Why is the Earth different? The answer lies in the nature of the void. The reason things stop on Earth is because of friction. We live in a thick, sticky soup of atmosphere. When you move your hand through the air, you are colliding with trillions of nitrogen and oxygen molecules. You are pushing them out of the way. That takes energy. When a car drives, the tires grind against the asphalt. The air pushes against the windshield. The internal gears grind against each other. All of this friction steals the energy of motion and turns it into heat. That is why you need fuel, to constantly replace the energy that friction is stealing. But space is different. Space is the ultimate vacuum. There is no air to push against. There is no asphalt to grind against. There are no rusty gears connecting Earth to the fabric of space-time. This is Isaac Newton's first law of motion in its purest, most terrifying form. An object in motion will stay in motion unless acted upon by an unbalanced force. In our daily lives, we never see this law in action because there is always an unbalanced force. There is always friction. We intuitively think that stopping is the natural state of objects. But in the cosmos, stopping is not natural. Motion is natural. Once the Earth was set spinning by that ancient collapse, there was simply nothing to stop it. We are gliding on a frictionless surface of nothingness. We are not losing speed because there is nothing to steal it from us. Think of the Earth not as a machine that needs fuel, but as a battery. When the solar nebula collapsed, it charged the battery. It stored a truly astronomical amount of kinetic energy in the rotation and orbit of the planets. Let's look at the numbers, because the brutal mathematics here are staggering. But the kinetic energy of the Earth's motion, that is on a scale that makes nuclear weapons look like firecrackers. The energy stored in Earth's orbit, just a motion of us flying around the sun, is roughly equal to 2.6 times 10 to the power of 33 joules. That number is too big to visualize, so let's break it down. If you took the entire energy consumption of the human race, every power plant, every car, every light bulb, every factory, and you ran it for 1 billion years, you would still not even scratch the surface of the energy contained in Earth's orbit. We are riding a cannonball that has so much momentum that it simply cannot stop. However, cannot is a strong word, and in physics, nothing is truly eternal. Remember I said there is almost no friction in space. Almost is the operative word. Space is not a perfect vacuum. It is a partial vacuum. There are stray hydrogen atoms. There is the solar wind, a stream of charged particles blasting from the sun. There is the gravitational tug of other planets, like Jupiter, which pulls at us slightly. And most importantly, there is the moon. The moon is slowly stealing our rotational energy. As the Earth spins, the moon's gravity grabs onto our oceans, creating the tides. This tidal bulging acts like a brake pad. It creates friction between the water and the ocean floor. This friction is slowing us down. The Earth is not spinning at the same speed it was when the dinosaurs were alive. 65 million years ago, a day on Earth was only about 23 hours long. When the Earth first formed, a day was likely only 6 hours long. The planet was spinning violently, a molten ball of chaos. Over billions of years, the moon has been draining our battery. It is lengthening our days by about 1.7 milliseconds every century. It sounds tiny, but given enough time, the mathematics are inevitable. Eventually, billions of years from now, the Earth could slow down enough that it becomes tidally locked to the sun, just as the moon is locked to the Earth. One side of our planet would face the sun forever, scorching an eternal day, while the other froze an eternal night. The spin would effectively stop relative to the star. But that is a horror story for the distant future. For now, the battery is still full. This brings us to the bigger cosmic picture. This story isn't just about Earth. It is about the architecture of the entire universe. Everything spins. Asteroids spin, stars spin, black holes spin. Entire galaxies containing hundreds of billions of stars rotate like majestic pinwheels in the dark. Why? Because everything came from something else that collapsed. The universe is a hierarchy of collapse. Clouds collapse to form galaxies. Pockets of galaxies collapse to form stars. Disks around stars collapse to form planets. At every single level of this hierarchy, angular momentum is conserved. The motion is passed down from parent to child, from galaxy to star to planet. We are living in a universe of inherited motion. Like a river splitting into countless streams, the original movement of the early universe flows into everything that forms within it. The universe doesn't restart movement again and again. It carries momentum forward through time. So where does the energy come from? It comes from the past. It comes from a time before humanity, before biology, before the geology of our mountains. It comes from the moment gravity first asserted its dominance over the chaos of the gas cloud. The energy that whips your house around the sun at 67,000 miles per hour is a legacy. We are effectively coasting. We are drifting through the dark, carrying the momentum of our birth, trapped in a perfect, frictionless dance with the sun. This realization leads to a profound shift in how we see ourselves. We often think of the Earth as a stable, fixed platform. We build our cities, we draw our borders, and we anchor our lives to the ground. We think of stillness as the default state of existence. But stillness is an illusion. Stability is a temporary balancing act. We are not standing on firm ground. We are standing on a raft that is careening down a frictionless river, powered by a push that happened 4 billion years ago, held in a curve by the invisible tether of gravity. It is a system of terrifying elegance, a system that requires no maintenance, no fuel, and no operator. A system that works perfectly, right up until the moment it doesn't. Because while the orbital mechanics are stable on human timescales, the three-body problem and chaos theory tell us that on sufficiently long timelines, even the orbits of planets can become unpredictable. We are balancing on a knife edge of physics, kept alive by the precise value of our velocity and the precise strength of the sun's gravity. If the Earth moved slightly slower, we would spiral into the sun. If we moved slightly faster, we would drift into the freezing dark. We are in the Goldilocks zone of motion, not too fast, not too slow, just right. And we will likely stay here for billions of years more, not because of a divine hand holding us in place, and not because of a cosmic engine pumping fuel into our core, but simply because nothing has stopped us yet. The planet is not fragile. The physics are robust. The momentum is immense. But civilization? That remains as fragile as ever. We are just passengers on this high-speed rock, trying to understand the rules of the vehicle we are riding. If this deep dive changed how you look at the night sky, if the brutal mathematics of momentum resonated with you, hit like and share this video. Share it not just to help the channel, but because this information forces us to realize how small and how fast we really are.
And subscribe to Questhut, because our next quest is even harder. See you, Questers!